All right, so the quiz. It's now too late to submit the quiz, of course. So the main thing was to find the hypotenuse. Once you get the hypotenuse, I think the rest is pretty easy. Okay, so if you do your a squared plus b squared equals c squared stuff, you should get 17. 8 squared plus 15 squared equals c squared. 64 plus 225 is 289. Square root of 289 is 17. And then after that, it's just your SOHCAHTOA stuff, right? Okay, so a quick word. When you say the 6 trig functions, you're always supposed to put theta. Okay, I let it go this time, but I might not be as nice during the test. You're not supposed to just put sine, cosine, tangent, and so on. It's sine of theta, or whatever the angle is, sine of A or sine of theta or whatever. So sine of theta is 8 over 17. Cosine of theta is 15 over 17. Tangent theta is 8 over 15. And of course, the reciprocals. And that's pretty much about it. Okay, if I didn't reply to your quiz, don't worry, I'll try to get to it today. I usually try to make a 24-hour turnaround for any email. So if you sent it sometime yesterday, Sunday, I hope to get it by today. Okay. I don't know if you can imagine. I don't know. Well, you're not my only class that I'm teaching. Put it that way. How many classes am I teaching anyway? I'm teaching what, 6 classes overall between CSM and City College of San Francisco. So I try to get around to everybody. So out of all the myriads of emails that I get, of course, I'll get to yours sooner or later, but it may not be as quickly as you may want. But I'll try to do the best we can. Okay. So that is that. Now, on the schedule, again, we're done with this side, so that already tells me we're past the halfway mark once I get to this part of the paper, right? Okay, so we're over here. I was originally only supposed to be up to 4.3, but I'm way ahead of that. In fact, by today, I should be done with 4.4. Okay, so I hope to be finished with 4.4, even sneak in some of 4.5. We'll see how it goes. Bottom line, I'm ahead. Okay, so there's a good chance I'll finish early every day this week. In fact, maybe every day all the way up until the test. And even if I start to catch up or fall behind, I still got some buffer days leading up to the exam on November the 6th. Okay, so we're likely to finish my formal lecture early every day. Then I'll ask you questions, and if there aren't any questions, we'll just end early. Okay, so that's the way it's going to be. All right, so I'll go back to where I was in 4.4. Okay, so far no changes in the assignment. All right, so back to 4.4, please. Okay, last time I got up to problem 37. So I'm going to try to show you how to do most of the rest of these. Then I'll be done with 4.4. I'll sneak in some of 4.5. I probably won't do any problems with that, but graphs of the sine and cosine function. Again, all of this should be considered review, though. Trig. Okay. All right, so problem 39 I have over here. Let me just show you what's up with those. Find all values of t, the angle is t, in the interval from 0 to 2 pi that satisfy the given equation. Okay, the cosine of t, the angle is t, they could call it theta or whatever. Okay, the cosine happens to be whatever. Okay, so you're asking for the x-coordinate. Okay, the x-coordinate is whatever they asked for. So the x-coordinate is radical 2 over 2. Okay, so I know that x is positive in quadrant 1 and quadrant 4. Okay, so that's here and here. So all I need to do is label these angles. I know that's pi over 4. This one way over here is 7 pi over 4. So my angles are pi over 4 and 7 pi over 4. That's the answer to 39. Okay, and by the way, they want an answer between 0 and 2 pi. So that's why I should not say negative pi over 4. Basically, it's just one revolution all the way around. Okay, so that's that. 41, sine of t is negative a half. Okay, again, y coordinate. I want the y coordinate to be negative a half. Okay, so what I do is I draw myself a unit circle, and I just kind of go halfway down. You don't even have to be that accurate. Your circle doesn't have to be that accurate. It's usually good enough to tell what angles you want. So I go down like that, and I draw that angle and that angle. Okay, and I know that when I have an angle of a half, there's going to be 30 degrees, 60 degrees, something like that involved. So if I go like that and like that, right? That looks like 30 degrees. Okay, so I just have to convert that to radians now. This is pi. I add another pi over 6, so 7 pi over 6. And I have this angle way over here. Okay, that's 30 degrees. If I go all the way around, that's 2 pi. I back up pi over 6. So it's 2 pi subtract pi over 6. That comes out to be 11 pi over 6. Okay, so the two angles that I want are 7 pi over 6 and 11 pi over 6. Okay, so one here and one here. You could also say this is 330 degrees and then use the conversion factor. 330 degrees, convert that to radians, right? By multiplying by the right factor. In this case, it would be what, pi over 180, and it reduces to 11 pi over 6. Okay, now 45 is a little bit trickier because they have t over 2. It's not just t, it's t over 2. Cosine of t over 2 is a half. So what do I do if I have t over 2? The first thing I do is say to myself, I don't even want it like that. I like it to be just a single letter like theta. So why don't I just call it cosine of theta and change the problem into theta, and then I'll switch back to t a little bit later. Okay. So here we go, cosine of t over 2. And t is between, including 0 to 2 pi. So I say to myself, I don't want this crazy t over 2. Why don't I just temporarily call it theta? Cosine theta is a half. I like that better. So let theta be t over 2, okay, which means t is equal to 2 theta. I might need that a little bit later. Okay, so instead of doing cosine t over 2, I'll just do the substitute equation. Cosine theta is a half. Okay, I like that. Now I have to see what the bounds of theta are going to be. T was given to be between 0 and 2 pi. Okay. Then I'm going to divide all of these by 2. So what do you want to do that for? Because in the middle, I want it to be t over 2. If t over 2 is in the middle, then I will substitute that for theta. Okay. So right here, 0 less than or equal to t less than or equal to 2 pi. Divide everything by 2. 0 less than or equal to t over 2 less than or equal to pi. And the reason why I want that is now I will substitute t over 2 for theta, because it says so right here. Theta is equal to t over 2. So theta is between 0 and pi. Okay. So I need to solve this equation. Where'd it go? Cosine theta is a half. X coordinate is half for theta only between 0 and pi. Okay. So between 0 and pi. So I want the x coordinate to be a half. So I go halfway over, go like so. Again, it doesn't have to be that accurate. And I notice it looks like it's about a 60-degree angle, which is pi over 3. Okay, so theta is pi over 3. And that's the only angle. I don't want an angle over here because theta has to be between 0 and pi if t is between 0 and 2 pi. See, they gave us the limits for t, but I now have to find the limits of theta. All right, so theta is pi over 3, but the original problem involved t. So how do I find t? That's why I write down this relationship here. T was equal to 2 theta. Okay, so I just multiply this by 2. 2 theta is 2 times pi over 3. So my final answer is 2 pi over 3. And there we go. Okay. Okay, then let's see, 47 and 49. Determine whether the function is even, odd, or neither. Okay, so I'll do 47. Cosine x squared. Now, the usual way to write that is cosine squared of x. Okay, so I'm going to write it like that. Cosine squared of x. All right, so determine even or odd, you might recall I replaced x with negative x. So I want cosine of negative x squared. But it turns out the cosine of negative x is the same as the cosine of x. If, for instance, if I look over here, right? If I call this theta and this is negative theta, they have the same x coordinate. They both go the same amount this way. So cosine of negative x is the same as cosine of x. So I do have cosine of x squared, which is the same thing as cosine squared of x. So that tells me the number 47 is an even function. Okay, so cosine squared of x is even. Okay, then 51, what do they say in 51? Sine of t is negative 2 radical 2 over 3. Cosine of t is 1/3. Okay, again, that's x, that's y. Find the sine and cosine of all these other guys over here. Okay, so we have to figure out where we are. So cosine of t, that's the x coordinate, that's the y coordinate. Let's see, x is positive, y is negative. That sounds like quadrant 4. Okay, so what I did was I drew myself a picture like this. And then I'm over here. So 1/3 negative 2 radical 2 over 3. Okay. And what's all this other crazy stuff that I have here? Well, these are angles that you might need. Okay. So this is 90 degrees right here. If I draw a 90-degree angle, the reason why they do that is because I think in one of the problems it says something about pi over 2. Okay. You can tell by symmetry now the x coordinate and y coordinate, if you take this point and kind of turn it, these two would switch roles. In other words, it'd be 2 radical 2 over 3, comma 1/3. Or this distance from here to here should match this distance from here to here. And likewise, this distance here matches this distance if you sort of turn it. Okay. So that means, for example, 51a, t plus pi. So that's 180 degrees apart. So if I just go 180 degrees over here, that just reverses these. So a is negative 1/3, positive 2 radical 2 over 3. Okay, I don't have that written down here, but for a, t plus pi. So t plus pi, just reverse these, right? 180 degrees apart. So cosine of t is negative 1/3, sine of t positive 2 radical 2 over 3. Okay, B asks for negative t, the negative of the angle. Okay, so it lands me over here. The original t, let's suppose it was like so. If you got it like that. So the negative would swing around over here. I would land right here in the first quadrant. Okay. So if I'm in the first quadrant like that, the x coordinate stays the same, 1/3. The y coordinate would be the opposite, 2 radical 2 over 3. Okay, so the answer to part B is the cosine of t would still be 1/3. The sine of t would be the opposite, so 2 radical 2 over 3. All right, then yeah, I will talk about C quickly. T plus pi over 2. I add 90 degrees to the angle. So if I add 90 degrees, I would swing over to here. That would be exactly opposite this one. Okay, so this one would be negative, negative. Negative 2 radical 2 over 3, negative 1/3. Okay, so I'm over here. I add pi over 2, it says. I add 90 degrees. I'd be over here. Let's see. Oh, I'm sorry, I'm supposed to add 90. Adding 90 would be this way, right? Okay, I was doing a different problem here. Yeah, adding 90 would be over here because this way is considered positive. So yes, I would indeed land over here. So the answer to C would be, this would be the cosine. So cosine of t, 2 radical 2 over 3. Sine of t would be 1/3. Okay, so cosine, sine, that would be for part C. Okay, so that's as much as I want to do for that one. Okay, and then 53 is the last one I'll do, and then I'm done with the section pretty much. Find all t between 0 and 2 pi, satisfying 2 sine squared of t plus sine t minus 1 equals 0. Okay, so you might recall doing something like that in trig. 2 sine squared t plus sine t minus 1 equals 0. Okay, so I factor, pretend temporarily it says 2x squared plus x minus 1 equals 0. It's the same kind of thing. So it's a quadratic equation in sine of t. So how do I get 2 sine squared of t? 2 sine t sine t. How do I get 1? 1 and 1. And let's see, you want to end it with a positive. So let's see. Positive here and a negative here. That will give me, let's FOIL that out, right? 2 sine squared t plus 2 sine of t minus 1 sine of t. So that's plus sine of t, and minus 1 equals 0. Okay, so now either this one is 0 or this one is 0. 2 sine t minus 1 equals 0, or sine of t plus 1 equals 0. Do a little bit of algebra. Sine of t is a half, or sine of t is equal to negative 1. And that pretty much does it. Sine means the y coordinate. So what I did is I drew a unit circle. I went halfway up, y coordinate, going like that. So I have that angle and that angle. So that looks like 30 degrees, pi over 6. That looks like 150 degrees, or 5 pi over 6. And then sine of t is negative 1. Y coordinate is negative 1. That's down here at the south pole, as it were. And what is this angle in radians? 3 pi over 2. Okay, so it looks like I have 3 solutions: pi over 6, 5 pi over 6, and 3 pi over 2. Okay, and they're symmetrically placed around the circle, it looks like. So it looks like they're all, what, 120 degrees apart, I guess? Like that and like that. Yeah. Okay, so pi over 6, 5 pi over 6, 3 pi over 2. All right. Okay, folks, so I'm actually essentially done with the section. Okay, so I'll give you an introduction to 4.5, but won't do any problems with it. And then, so think of any questions you might want to have. I'll stop in, I don't know, 10, 15 minutes. And then I'll take any questions. If you don't have any questions, we're done. Okay, so introduction to 4.5, which are the graphs of the sine and cosine function. Okay, and again, I'm going to present in a review sort of lecture. So this should not be the very first time you've seen it. Okay, so I'm not teaching you guys as if you've never seen it before. I'm teaching it in review and just try to jog your memory. Oh yeah, I saw this or whatever. Okay, all right. So we could go around a unit circle, and they have some various key points here. Okay, so on a unit circle, as you go around a unit circle, we've already seen it. Okay, the cosine of the angle is the x coordinate. Sine of the angle is the y coordinate. Okay, so you can come up with this. So there's a little chart. This is on page 220, if anybody wants it. So they get key angles: 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, 7 pi over 6, 2 pi. Okay, going around the circle, they pick the y coordinate. Okay, so the y coordinate all the way through are these numbers. Okay. All right. If you plot these, x versus y being sine of x, you get something that looks like this. Okay, so you should already recognize that the sine function looks kind of like this. Okay, for one period, we start at the origin. So the sine touches the origin. It goes up, then down to 0, down, back to 0. That's considered one period, but it keeps going. So they're just trying to show you now. Okay, so here's one period, right? From 0 to 2 pi, right there. They're just trying to show you it keeps going on this side, and it keeps going. In fact, it keeps going on forever, right? But you get essentially all you need between 0 and 2 pi. And it's almost like just copy and paste, right? Take that picture, copy, paste it all the way here, and paste it all the way there. Right, so that's the graph of the sine function. Okay, you can do something similar for the cosine function. So if you have a unit circle, again, you could pick certain key angles, and this time as you go along, you want the x-coordinate. So you can make a very similar table. This is on page, what, 221 it looks like? So x versus cosine x. Same angles, 0, pi over 6, pi over 4. If you want to know what these are, this is what, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120 degrees, and so on, right? You could convert those if you need to. And the cosine. So cosine of 0 is 1. If I'm on a unit circle, if I start off this way, right here, right? If I have 0 degrees or 0 radians, what is the x-coordinate? The x-coordinate is 1. And then it goes around like so. So if you just give me the x-coordinate, right, then it goes like this. 1, radical 3 over 2, radical 2 over 2, 1/2, 0, and then it becomes negative, and then it starts to become positive again. Here they are, right? So you've seen this before. You can find it on page 221. It's on the recording also, if you need it. So plot out the points. Cosine looks like this. And again, it repeats every 2 pi, just like the sine function did. Okay, so unlike the sine function, the cosine, one period begins at 0, 1, goes down and back up, and it just repeats that over and over. Okay, so again, this is one period between 0 and 2 pi. And then just imagine you copy and paste, it just keeps going like that, up and down, and over here it just keeps going up and down. All right? Okay, a little bit of symmetry. Sine is odd, cosine is even. That means y equals sine of x has origin symmetry. Symmetry with respect to the origin because it's an odd function. The cosine function has y-axis symmetry because it's an even function. Okay, so if you take the cosine function, if you put a mirror right there, right, and you reflect everything on the right side over here, then you get the same thing over there. And likewise for the sine function, if you reflect across the origin, they didn't show you that much over here, but that point, if you hit across the origin, comes all the way down here. Or this point here would reflect all the way up here and so on. Okay, so that's a property of origin symmetry. All right. Okay, and then you can do various things to the sine function. Okay, but let me show you my version of it. Okay, so my version, graphs of the sine and cosine functions. Okay, so we have these key points on our unit circle, 1, 0, 0, 1, negative 1, 0, 0, negative 1. Now, I don't put as much detail as the book did. You can look at the book with that. But at least you can see these. So for 0, 90 degrees, 180, 270, 360 degrees, pi over 2, pi, 3 pi over 2, 2 pi. These are sometimes called the quadrantal angles. Quadrantal angles, they lie on the x or y axes, like 0 degrees, 90 degrees, 180, 270, 360 degrees, or pi over 2, pi, 3 pi over 2, 2 pi. So look at what I got here. I'm asking for the x-coordinate as I go around the circle. So the x-coordinate is 1, 0, negative 1, 0, 1. There it is. 1, 0, negative 1, 0, 1. The sine of the angle, sine of theta, give me the y-coordinate. 0, 1, 0, negative 1, 0, 0, 1, 0, negative 1, 0. Okay, now I wasn't in as much detail as the author, but you plot the points and more points, looks like this. Okay, about domain and range. The domain of the sine function is all real numbers. The range is bracket negative 1 to 1. Okay, so the sine of an angle is stuck between negative 1 and 1, including negative 1 and including 1, but we can go as far to the left and the right as you wish. Okay. Now what is this thing here? This gives you one period of the sine function. Starts at 0, goes to a maximum, and then 0, and then a minimum, and then 0. Yeah, in this case, the maximum is 1, the minimum is -1, but later on, we're going to do stuff to it where the maximum or minimum might change, right? So it goes 0, maximum, 0, minimum, 0. That's one period of the sine function. Okay, let's look at the cosine function. Here's one period. Okay, so if I plot these points, right, 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, 2 pi 1, like this. Okay, so here is one period, and that's just, again, to indicate it keeps going. But here is one period of the cosine function. And once again, domain is all real numbers. You can go as far to the left or to the right as you wish. And the range is bracket -1, 1 bracket. Okay, you can only get numbers, again, between -1 and 1. And here's one period of the cosine function. Starts off at a maximum, then 0, minimum, 0, maximum. Okay, and I hasten to add, if you all of a sudden multiply by -1, let's say, then this would bounce down there. You would actually start at a minimum. Okay, and yes, in this case, the maximum and minimum are 1 and -1. But again, if you multiply by something, then that changes the maximum and minimum, as we know, right? So one more time, for the sine function, one period goes 0, maximum, highest point, 0, minimum, 0, 0, up, 0, down, 0. Even this 0 might change, right? Like if I take this thing and all of a sudden +1 or -3, then that'll move the graph up or down. One period of the cosine function, maximum, 0, minimum, 0, maximum. And again, I say 0, but again, if I do like a +1 or -2, then that'll change this also. Okay. Okay, now I want to show you the general setup that, again, you've probably seen that before in trig. Okay, so y equals a, either sine or cosine. Okay, it's a little bit trickier when you do tangent, cotangent, secant, and cosecant, but at least for this, a, sine or cosine, b, parentheses, x minus c plus d. Okay, so I think you've seen this before. A controls something called the amplitude. Okay, the amplitude is the absolute value of A. So let's say this was a -3. I would still say the amplitude is +3. Okay, the B controls the period, although the B is not the period. The period, I will abbreviate amplitude with amp. I'll abbreviate period with PER, so I don't have to keep writing the whole thing, and you don't either. Okay, the period is 2 pi over absolute value of B. Very rarely will they give us problems where this is a negative. Okay, so we usually just say 2 pi over B. Very, very technically, it's 2 pi over absolute value of B, but they almost never give us stuff like that. So the period is 2 pi over B. And this is just a horizontal and vertical shift that we've seen before, right? So when it's written like this, x minus c, okay, that's a horizontal shift, and d is a vertical shift. So example like this, right? Y equals 3 sine of 2 parentheses x minus pi over 4 plus 1. I would say amplitude is 3. Period is 2 pi divided by 2, which is pi. And what does this do? That's pi over 4 to the right and 1 up. Again, watch out. Remember, if this is a minus here, you're moving to the right, not to the left. That's counterintuitive. Okay. This one is directly up. So how would I go pi over 4 to the left? This would have to be x plus pi over 4. And what would make this go 1 unit down? That would be a minus. Okay, so I have some example graphs involving amplitude and period, and that's about it after that. So I've got less than 5 minutes left. So if anybody wants to ask the questions after that time, you can have it ready. So be ready to type it in the chat perhaps, or unmute yourselves. Otherwise, we're done. Okay, so in red, I have the regular sine function. Okay, goes 0, 1, 0, -1, 0, or 0, maximum, 0, minimum, 0. Okay, now if I put a 2 in front, the amplitude is 2. And we also have a very formal way of getting the amplitude. It's maximum minus minimum divided by 2. Okay, now here you might say it's obvious, but if there's a shift, it's not as obvious. Okay, so 2 sine x. So the 0 stays the same because 0 times 2 is 0. Here, the maximum was 1. Okay, but let's say this thing came out to be 1 sine of x. By putting a 2 in front, that makes it go up to 2. And likewise, suppose this thing at 3 pi over 2 came out to be -1, the red one. Now, if I multiply by 2, it's down at -2. So the zeros stay the same because 0 times anything, any coefficient is 0, but the maximum goes twice as high, the minimum goes twice as low. So in green is the graph of 2 sine x. So the zeros stay the same. That stays the same, that stays the same, that stays the same. Imagine this thing got stretched up to there, and this gets stretched down to there. Okay. And formally, we can get a formula for amplitude. It's maximum minus minimum divided by 2. What's the maximum? 2. What's the minimum? -2. So if I subtract, what's 2 minus a -2? 2 minus a -2, that's 2 plus 2, which is 4. Divide that by 2, and the answer is 2. And yes, again, in this case, you might say, well, it's obvious the amplitude is just a coefficient, 2. Yeah, but it's not as obvious when you have some shifting, and maybe we'll do some problems later involving that. Okay, I want to show you -2 sine x. Now, how do these two functions differ? The negative just reflects across the x-axis. So look at the green, ignore the red. This one was like that. It bounces down to here. And likewise, this one, which was down here, comes up like so. So the red is the original sine function. -2 sine x goes like that. And again, part of the logic, okay, if this thing ever comes out to be 0, multiplying by -2, it's still going to be 0. So notice the zeros are still the same. That's tied down. That's like tied down. That's tied down. But what about this one? Here, the y value was 1, right? If that came out to be 1, now if I multiply by -2, it's down here. So not only is it on the other side of the x-axis, it's further down. And yes, likewise, here the y-coordinate was -1. If that was -1, if I multiply by -2, now it bounces up to here. So it goes like so for -2 sine x. We're still going to say the amplitude is 2. By formula, it's the absolute value of A. So we want amplitude not to be a negative number. Amplitude is always positive. And notice if we still play the game of maximum minus minimum divided by 2, it still works. Amplitude is 2 minus a -2, that's 4, divided by 2. Okay. Okay, then just for fun, I'll show you -3 cosine x. So in red is the original cosine function. Cosine goes maximum 0, minimum 0, maximum. So maximum is 1. So look at the red is the cosine function. 0, -1, 0, maximum. Now multiply by -3. Well, 0 times -3 is still 0. So the zeros stay put. These two stay the same. Now what happens at 0? Cosine of 0 is 1. Okay, that's that red point right there, that red point. If you multiply by -3, down on -3, so it bounces over to here. And same thing happens over here. Okay, if that comes out to be 1, this comes out to be -3. Then how about at pi? Cosine of pi is -1. -1 times -3 is +3. It jumps way over here. So -3 cosine x. And by the way, we would still say it has the same amplitude of 3, right? Then instead of starting at the maximum, it goes minimum 0, maximum 0, minimum, which is exactly the opposite of this. And that makes sense because I multiplied by a negative number. Okay, I'll show you a couple of changes in period, and then I'm done. Y equals sine of 2x. Okay, so the amplitude is still 1. It doesn't go higher or lower, but the period formula is 2 pi over b. This is the b. 2 pi divided by 2 is pi. So I finished one complete period after pi. Okay, so in red, if you look at the red, that's the sine function. Finished everything in 2 pi. However, here sine of 2x, it finishes that entire up and down stuff by the time I reach pi. It's almost like you take the red one and just kind of scrunch it in. Just jam it all in here. Or imagine you have a spring, right? Imagine this is a spring, and you just kind of jam it in like that, okay? Then you'd have to finish everything by the time you reach pi. So in green, you do that one cycle of up, 0, down, 0. It finishes all by the time we reach pi. So it looks like that. Okay, on the other hand, what if I have a number like cosine half x? Okay, cosine half x. So the amplitude stays the same. It doesn't go any higher or lower. But the period is 2 pi divided by a half. Remember, dividing by a half is the same as multiplying by the reciprocal 2 over 1. So when I see 2 pi divided by a half, that's 2 pi times 2, which is 4 pi. So whereas in red, the cosine function normally finishes a period in 2 pi, right? The sine function, the cosine of half x, it gets dragged out. So it's almost like take the red function and stretch it out that way, pull on the spring, as it were, and it takes 4 pi to finish an entire period. Okay, so one more time, in red, regular cosine function finishes everything in 2 pi. So this red is supposed to match this red, so to speak. But now stretch it out. So now look at the green. It takes a much longer time for it to finish one period. It has to go all the way to 4 pi, doing the maximum, 0, minimum, 0, maximum. Looks like that. Okay. All right, folks, so that's it. That was my introduction of 4.5. I wasn't going to do any problems with it. But again, it's one of those things where whatever introduction I did today, that just saves me time for tomorrow, hopefully. Okay, so we're here. I will get started with 4.5 tomorrow. I wasn't originally supposed to start 4.5 until Thursday. So again, we're doing pretty well time-wise. Okay, so let me stop the share and check the chat. And I don't have anything in the chat. Okay, so does anybody want to ask any questions? And if not, we're done, folks. Anybody with a question? Okay, that's it, folks. I know some of you just submitted your quizzes or you submitted yesterday. I'll get to them hopefully by today, and I'll email you the results for that. All right, that'll do it for today, folks. So everybody have a good day, and we'll see you tomorrow. Okay, bye, everyone.